Recording. Yeah. So as we are discussing about the containers, right? So we have a mission with these are the storage parameters. These are the vision parameters. So we have the namespaces and C groups. So coming to the namespaces, tell you like CPU, memory, storage, also network, and we have process isolation. Okay, and we do have multiple some more things as in processes in PID. Yeah, we do have some other parameters, but these are the main things. Okay. So the other parameters include UTS, host name, and message queues, users, and time. Okay. So, so what do you mean by isolation? So isolation is nothing but so we are saying like okay, this particular container. So we will provide a some specific resources. So when we go inside the container, it will feel like okay, it has a particular CPU, memory, and all other things parameters, and it itself will feel like okay, hey, I am an operating system, so myself, okay. So we are providing that conscious that a container, okay. So yeah, so the isolation provide will also provide a specific network. Okay, I'll show you how it is. So coming to the C groups. So C groups provide a control over the okay. So is the CPU we can allocate, okay, or how much is the storage we can allocate. So when we are providing this particular container, these resources, so there are chances that it can go beyond and all. Okay. So yeah, we can provide a limit how much is the CPU it can utilize, or how much it can exceed and all other things. Okay. So we'll go in deep. These particular things will go in deep in another session one more time, and we'll go through the containers in a bit in a different direction. So why do we need this container? So first thing is isolation. Okay, and easy to manage and easy to spin. Okay. So the isolation part we discussed. Okay. So management as in, okay. Yeah, let's come back. So easy to spin up, like the time take to spinning up VM. So what do you mean by VM? A VM can be, you have a hardware. Okay. So there are two levels of virtualization. Okay. One is VMware hypervisor, which is sits on your bare metal OS. Okay. And the one which we use, uh, this is virtual box. So we do use for regular purpose. Okay. So here we are using the virtualization concept, and we are interacting with the kernel. So this is how we are spinning up the virtual box. So it will talk to the hardware through the kernel. So it will share the kernel, and we are talking to it. And here also we are providing the resource allocation and all other things, similar concepts we are providing here. So when we are spinning up a virtual box, so we seen like what is the image it should run, okay, what is the process it should run and all other things, okay. And coming to the yeah, so coming to the other concept, right? So containers. So why do we the easy to spin up concept? So when we are trying to spin up a virtual box, okay, so as in yeah, as a Ubuntu OS or a RHL OS and all. So, however image small it could be, so it might take at least 2 to 5 minutes. And once it is done, so there are three. If any of you are sysadmins, so you might know what are all concepts are involved here, right? Yeah. So if someone is here sysadmin, or if someone is a regular user, okay, regular PC user, okay. So if you take a Windows machine, so when you are spinning up a new laptop, okay. So what will you do? First thing is a OS, okay, and then you will install all your regular things. Which one would be Microsoft Microsoft Office, okay, and then you will install all your games or something. Okay, and if you do have any of your office applications, or do you need a drivers and all, right? So that one will come here. So this whole setup takes, let's assume, 2 hours for a regular user. Okay. So the sysadmin, what sysadmin does, so once he set up a VM, so let's assume we are supposed to run a Python code. Okay. So for that, he needs to install Python. Okay. And then he needs to copy the code and run the code. So if you, even if you're thinking of automation or using some other softwares to automate it, okay. So even with the span of automation, this might take somewhere around, you can bring it up to 10 minutes. Okay. So max to max. Or let's say if I use a very light version of OS, if I, maybe, yeah, let's take 10 minutes. Okay. So including with automation steps of all these things. Okay. Let's say we are in a production setup. Okay. Now, what happened is, so in this production setup, you have somewhere around 100 VMs. Okay. Now, let's say in this 100, so if you say like, hey, why can't I use a clone and backup and all? So you will have a problem with the IP address mismatch. Okay. So you'll have a problem with the host name mismatch and all. So we are supposed to use a magic template VM. So we might discuss when we are bringing up the AWS things and all. So whatever automation we use, so we can take 10 minutes as a standard time. Okay. So in the production high level environment, so we are trying to use somewhere around 100 VMs. Okay. Reason, you have your 10% of VMs, let's say 10 VMs. Okay. Or 5% of your VMs got killed off. Okay. So even you have a big team, in order to, if they are working in, it will take five. If they're working in parallel, it might take 10 minutes to, or let's say if there is a one guy who is trying to do some automation and bring up the things, maybe 15 minutes, since it is a automation, or 20 minutes. Okay. So in the production environment, this kind of time is very critical. Okay. So like can't I spin up very much quickly and all. So that's where this container concept will help us. Okay. So it could maybe it might take five seconds, or it depends. Like if the image is too much, it might take 30 seconds, or maybe if it is like heavy image, it might take 1 GB, but we'll not go to that part. So that's about the spin up part. Okay. Any questions here about the concept I told? Okay, I'll move forward a bit. So, the next thing is management, as in the upgrades. Okay. So, yeah, as in the spin up and recovery. Okay. So, management upgrade, as in what happens. So, we don't use the just a container ourselves. So, we use some container management. Okay. To manage the things. So, we will discuss about the container managers. We call orchestrators. Okay. So let's assume we have a version of 1.1 running in. Okay. Let's assume tomorrow we want to spin up to 1.2 or something. Okay. So just needs a small change. Like let's assume these containers count is some. Okay. So we will think about the deployment strategy, but keeping that part aside. So if we want to close the containers, or if we want to spin up a new containers and all, so all this just takes a parameter. Like we'll just go into a config file, just update it. So whatever configuration we want, it will come up. And even so if it is 1.1 version, we want to spin up to 1.2, all you need to do, go into a config file and update it. So your orchestrator takes care of upgrading. So far, yeah, if anyone is new, that's about the advantages, the main level of advantages about the management and upgrade, and also the resource utilization. As in, we will try to use all the resources in our hardware machine up to 100%. So we'll not go anything as wastage and all. So yeah, that's about it. And also we have something called environment friendly, as in uh, yeah, you have that word, right? Okay, so it works in your mission, not in my mission. So like here, let's say if someone asked me a code yesterday, so how do you give a Python code to others? How do you share a Python code to others? So like I told one thing, like, okay, maybe we'll share a Python binary to that guy and all. Okay, so what happens? Environmental stability or compatibility. Yeah, that's a better word. So he, okay, if anyone who works with Docker closely, right? So now what we'll do is, so once we spin up a Docker, okay, so we have to make sure, like, once the Docker image, sorry, the container image, it's a container image. Okay. So what we do is, whenever we are spinning up a container image, so let's say if the format is different, of the OS format is different, something like one is RHEL based kernel and another is Debian based kernel. Okay. Debian as in Ubuntu. Okay. And also there is something other formats as well. Right? So when we are providing the binaries to the users, or when we are providing the containers to the other people, make sure to provide them to their compatible operating system formats. Okay. So now that's, you don't need to do anything. So when you're spinning up or when you're building it, so the building will automatically detect what kind of operating system you are in, and also the hardware, and it will provide a compatible image. So something like, let's say, I'll take a name Money. So he's using some Mac operating system. Okay. So all I do is I'll provide my code and I'll provide a Docker file for now the reference. So I know for sure this will not working. Okay. So yeah. So what we do, we'll build a Docker image. We'll ask him to give it. Okay. The one which I wrote is in Linux, uh, but a different hardware. I'll hardware part. So I wrote this one. I combined created a Docker image. So I asked him to run in. Uh, he might have an issues. So what he can do, simply, he will take the source code. He will build a container image which is compatible, Mac compatible, and he will run it. So that's good to go. So you cannot say like, hey, this is working in my machine, why it's not working in your machine. So that things can be, dealt with Docker. So nowadays, if you take any repository source code, right? Like whoever is writing any code, what they are doing, they are making sure to write a Docker file also, so that they don't need to use the code directly. So they can build a Docker image and then they can run it. Okay. So this became an, okay. And now the latest norm is they're providing Kubernetes file also. Okay. So we'll come back to this part later. Uh, yeah, this is about it. So now question. So we worked on Docker here, right? Okay. Let's assume this mission is yeah, whatever Mac I have, whatever. I have, that is x86. Okay. And as I told, I have a Raspberry Pi here. Okay. This one. Now is okay. These are all two hardware concepts, how the processor and other things works differently. We discussed earlier, but the hardware basically it will be in two types. So whenever someone provides a software, they will provide in these two versions, whether what is it, x86 64, AMD they call. Sometimes they might name it AMD or something. Okay. So, and is ARM. Okay. So now my question is, so let's say someone built an image, okay, this x86 machine. So can I go ahead and execute it ARM mission? Does it work directly? So anyone would be able to answer here. Uh, yeah, Mani, would you like to try, man? Uh, yeah, go ahead, please.
One second. Sorry, Datta, can you repeat the question? I
Yeah. So
missed. Hmm.
let's assume you have a Windows machine, okay, or
Okay.
a
Hmm.
uh, yeah, you have a Windows machine or a Linux machine. Okay, basically you have
Okay.
a Windows. So you built a container, the Docker image. Okay, in the Linux compatible format. Okay, you have your
Okay.
regular. Basically, you have a, Linux operating system installed. This one, virtual box on top of it.
Right. Right.
Okay. So now what you did, you took this image into image registry. So we build a Docker image or a container image.
Right.
We pulled into registry, image registry. And now I what I told is, hey, why don't you take this Docker image, which I already built, and do a
Hmm.
pull on ARM mission, something
Yeah.
like your Raspberry Pi or Mac.
Yeah.
Okay.
Yeah. Yeah. Yeah.
So yeah, my question is, does it work? Does it cause any issues?
Uh, Not as far as I remember. We can pull them
Yeah,
and
we can pull them,
yeah,
but
we
we
can pull
cannot
them.
execute
Yeah.
them. So why? Because as I told, the
Hmm.
software said they'll release in a different formats, and there is a compatibility issues. So ARM machine cannot run the process designed for x86. Okay. So if you go
Okay.
to Docker Hub, yeah, say let's take something like Postgres. Yeah. So if you see here, right, they are providing different versions.
Oh, okay.
So
I
you
always
have
thought there will be only one image, like one image for all operating systems. That was my
no, not
understanding.
exactly. Yeah.
Okay.
So sometimes I'm not sure about the operating system. Yeah, the Windows and the like the Linux, the Mac, of course, it might change. But for architecture, right, as in the hardware, yes, there is a two different things. So based on your hardware version, whether it is a ARM processor or x86 hardware, right? So your
Right.
image. Okay. So I kind of faced this issue where I built a Docker image for myself and I was trying to pull it in a Raspberry Pi. It was able to pull, but it was not able to execute. So because of the same issue. So we
Okay.
build this whatever the Docker image. So we build this on top of a 86 hard. So when we are running it on different one, so we are supposed to build a separate image for the ARM or AMD hardware image. Okay, so that part
Right.
we need to make a note. Okay, and
Hmm. Okay. Okay. Got it. I mean, this is something different I learned today.
coming to one last concept. Yeah, we have time. So one coming to one last concept is how the image is built. Okay, so we do have a bare metal operating system, as in base the regular operating system. Okay, so in this we have some utilities, right? User utilities, something like Notepad. Okay. You have sudo, you have bash, okay, and you have a
Okay.
kernel and level things, okay.
Right.
Uh, like this, multiple things are there. So what we exactly do is we will take a plain Ubuntu image. We will
Mm-hmm.
remove everything from this, okay, and we
Right.
will provide a minimal operating system, okay. So that
Right.
minimal OS for the baseline for your container.
Okay.
Yeah. So
Yeah.
what
Yeah. Yeah.
when, like, let's assume this is somewhere around so once we remove everything, okay, we just need a operating system, the core operating system part. So operating system does so many things. Okay. So for, let's say, goal is to run only Ubuntu a shell script, or to run something like a Python code, or something like a Nginx
Mm.
or Node.js. Okay. So based on our, so we will take a minimal plain version, and then we will run whatever thing. And in that, one standard, one plain version is Alpine. So this is a very small image. I don't remember, like some 100 MB or something is there.
Right.
Uh, yes, sir. So I'll be going concept. So about the how the container interacts with your operating system hardware and all. So any doubts or things like you want to ask, whatever discussed till now.
So, okay. I have one doubt that too. So you have explained that we will go for minimal OS and then we will have our own software changes on top, and then we will like you know create a container image for single version of the like operating system, like hardware, basically ARM or RISC or in x86 or whatnot, right? So now I have one more doubt. Can we create the container image for different hardware architecture on, let's say, ARM architecture? Using ARM architecture, can I do it with sorry, can I create image for like x86 or different versions, basically RISC or anything like that, or is it restricted one hardware, one version of the container?
Yeah. Can you hear me now? Hello.
Yeah, I can hear you. I can
Yeah, I
hear.
can
Uh,
hear you.
Okay, thank
Okay.
you. So yeah, you asked one question. So something like, so this happens in like this. So you have a Docker code, as in the container code. You have an image. So there is a process called building, which will pack your container code into image. Okay. So
Okay.
your question is, so can I build a image for different architectures, right? ARM and this one, correct?
Right. Right.
Okay, you can do it, but it comes to your standard question. Okay, let's say you wrote a program. Okay,
Okay.
you want to execute it in ARM process, ARM machine. Okay,
Okay.
for that, what you need to do is you need to build it. Okay, or you need to compile it
Right.
in ARM machine, right? So this stays same for x86.
Okay.
So that's it, sir. So if you have a machine, hardware machine, whatever you have, or if you need hardware, software, other things and all. So if you have that, you can compile in that particular machine and you can produce the output. Okay. So you cannot
Okay.
compile a x86 container in ARM, right?
Right.
So how that exactly happens? So if you take the Postgres, right? So they're producing these images, okay, and somewhere there will be their source code. Yeah, this one.
Okay. Okay.
Yeah, if in like in the last session we kind of discussed about the workflows, okay, what
Right.
exactly
Right.
goes, and okay, they're producing different versions also. One second, boss. So
Yeah, that's what. Yeah.
there is no releases.
I don't think they are doing it here, like in GitHub.
I will take Jenkins. Okay.
Okay. Yeah.
Yes, sir. So if you see here, okay, I'll
Right.
increase the. So here they are pulling from AMD 64. Okay, the
Okay.
platform.
Right.
So Docker pull in a platform as a platform they are doing it. Okay,
Okay.
and that is AMD 64. Yeah, this is also AMD 64. Yeah, somewhere. Yeah, this is for ARM 64 they are doing.
Okay.
Okay.
Okay. Okay. Yeah. Yeah. Yeah.
So for different platforms, they're doing it. I don't know if I can do it on a same hardware machine, or okay, or they're pulling a different what is it, missions and all. So yeah, that's how we can do it. The platform dependency we can provide that. That's how. So when we are
Okay.
building it, right, I think we can give that one as in the we or when we are pulling the image. So we can pull the image like okay, I want this particular platform image and all. Okay. And I do not know exactly how the building part works here, but
Hmm.
yeah, that's how it is. Yeah. So
Yeah.
first they're pulling Docker. Yeah, that's all, sir. It is somewhere. I'll try to figure out.
Sure.
So, but I think there is a hardware dependency, but I'll check that one.
Hmm. Yeah. Yeah. Got it. Got it.
Yeah. So with this, I'll move forward to the next one. So we have same thing. Hardware. The operating system. On top of this, so we have high level things. Okay. So low level things we have Runc. So this is called container runtime. Okay. On top of this, we have something called the Docker would be here, and we have our container D, and we have Cryo. So this is the both are same things. Yes, sir. So this rocket LXC. So yeah, before coming to here, like a brief history. Like this container concepts is there in Linux from very long time. This is called LXC. Okay. Yeah, this is Linux container LXC. So this one has been there from very long time, as in 2008. They say like there are internal things which are like there from very long back. Okay. So the earlier version of containers is this one, LXC. Uh, okay. So if you see our capabilities, right, do we need? We need something like okay. So we need something like okay to manage the images, manage and build images. So that would be we have Docker and Builder, and we want something to write the content, write the Docker files, and write and to say publish it. Let's say to write we use Docker file, and we have other things also to manage the images. I mean to manage the containers. Okay, so that one would be Podman. Okay. So we have these three responsibilities. We want to write a file, we want to build it, we want to manage the containers and all. Okay. So if you see here, uh, Rocket has been very old one. Okay. I never used Rocket, but all I just heard of it. Yeah. For native container, it's been an old one, so it works in a different purpose. So we'll get to that. Okay. Let's keep this one. So the earlier version, we have the LXC. Now we have the container D. So what exactly happens? So now you have a hardware, you have the kernel and user space, and you have a operating system. Okay. So you need something to interact with your operating system. Okay. So like I would like to send that. Yeah. So this particular Runc and gvisor, right? So these two things, they will talk to the operating system. So why do they need to talk to operating system? So the things which we discussed, right? Something like yes, sir. So the control groups, CPU isolation. So all these concepts in order to utilize. So these things will talk to the operating system. And earlier we have a Docker shim. Okay. So which can talk to directly to Runc. Okay, which can talk directly to Runc. but this part they removed it for security issues. Okay, so in the Kubernetes, so they officially like retired it. So this container D is your open source project. This is also open source project. So we have Scrio, like coming to Runc and gvisor. So basically, what they do, they just run the containers. Okay. And what is gvisor? Gvisor is like a secure space somewhere, like you, in order to do something, let's say you're doing something core critical, you would like more secure container and all. In that case, you can go for gvisor as a runtime. Okay. And we can manage our images and all other things with this container D or Creo, whichever works out for you. So mostly we'll go for container D. And LXC is a very old version of Linux containers. So earlier, before coming up the Docker, so we have LXC to manage the containers and all. So we'll keep this out of picture for now. Yeah, we have a Docker and we have a Podman now. Or people are using container D to do the things. So that's about the, like, you might hear going forward, you might hear these names in place to place sometime and all. Okay. So that's about it. So any questions here?
Yeah, like so container is it used to manage the containers you're saying?
Okay. Yes, that's correct. So you can run the container and you can manage the container. Okay. But in order to, that's just a spin up, like, let's say high level of the things. It's like, okay, you told like, I asked you a task. Okay. So, hey, go ahead and spin up a instance, or go ahead and do this thing. Okay. So it's like you'll say, yes, I'll take care of it. But inside in depth, right? So what exactly you will do? You will go ahead and open the okay, or go to your office, open the laptop will spin up, okay, and then your operating system will load, okay. So that means you're interacting with someone, okay, in order to do your task, right? So that someone is this one, or you have a dependency, right? You cannot talk directly to your operating system, okay. So you need a middleman. This middleman is your Runc. Okay, so with container D, yes, you can spin up the images. Even with Cryo, also you can spin up the images. So container runtime. And we have something called container runtime. CRI initiative, sorry. So CRI initiative, it's for the Kubernetes. So what they told is, boss, whatever the containers you are doing, the container D, okay. So whatever you are doing to manage your containers, so make sure it's compatible with Kubernetes. For that, they gave this one, container runtime initiative. So make sure it matches with that. And Docker is a, let's say Docker is a supervisor kind of thing. The container D is the one which you use, but the Docker is a supervisor kind of thing. It has multiple things. So you can write the Docker file, you can build it, or you can use to manage the containers and all. But Docker, it basically uses the container D. Okay. So can I myself, like, can I go ahead and run the images myself just with self container? Yes, you can do it. So, but people got so used to Docker from very long. We are Docker mostly, most of the time. And there are, yeah, so there are some companies which got, yeah, there are some companies which got rid of Docker. So you can just use container D to do the things, or Cryo, depends on your use case. Yeah.
Okay,
Any
so
other
Docker is
questions?
like a interface for us to make things easy, but underlying thing is container D or Creo.
Yes, exactly. So
Okay.
earlier, as I told earlier, it was using Docker shim. We might discuss about the Kubernetes level and all. So Docker shim is there, but they removed it. They told, see, your Docker shim is not compatible with the CRI initiative. So they told, just get rid of it. So now Docker is matching with container D to do the things. That's it. And who tells it all these things or who manages all these things and all? So we have something called CNCF. Okay, so CNCF is cloud native CNCF foundation, right? Yeah. A computing foundation. So CNCF is cloud native computing foundation. So why we didn't discuss about this particular till now? So there are things in DevOps, so which are under CNCF and which are outside of CNCF. Okay. So some things we keep it outside of CNCF, and some things are which are control of this person, this particular body, as a representation. So what they do, they encourage the developers, they encourage the people to build the new products. Okay. And this was earlier partnered with Google. Okay. So they provide the fund. I'm not sure exactly how it works now. So what they do spin up the initiatives. They do talk about like, okay, hey, go ahead and educate the people about how the cloud native workspace works and all. Okay. So if you see run container D, it was a CNCF project. Okay. So Docker is not a CNCF project. Container D is a CNCF project. We have, I think gvisor. I'm not sure which one it is. So half of the projects, whatever you see in the DevOps space, so they are graduated by CNCF. What do you mean graduated? It's like, okay, tomorrow of some other initiative. Let's say you became a golden developer and you thought, okay, replace some version and you want people to use it or you need a funds to go through your project. So you can approach this person. So they will contribute to your project and they will help you graduate it. So like that, we have multiple projects. Okay. Yeah, that's about it. Yeah, Supreet, do you have any questions?
No, I missed last class, but did we discuss about the difference between virtual machine and container, like the basic differences?
Yeah, like so. Yeah, we did in a bit, but not exactly. So as I told, the virtual machine we do share the kernel basically. Okay, so we do as in like we do share the hardware resources. So we do share the kernel. Okay, and we have two types of thing. One which runs on bare metal, minimal bare metal and all. That is VMware hypervisor. Okay, and we have virtual box or yeah, we have Oracle virtual blocks or VMware workstation. All other things. I'm not sure if this is there or not. So we have virtual box kind of thing where we will run on top of a operating system. Okay. And we have something in Mac. If you are a Mac user, you would have heard of multipass. Okay. So similar things are there. So which we can use the things. So what exactly is a virtualization or a virtual box is? So yeah. So basically what it says is yeah. So basically, what it says is, so I can spin up a new operating system, okay, completely, and I can feel it behave like, okay, it's working on its own. It has a particular hardware resources and all. So we do share the hardware, we do share the kernel. So it itself behaves as, okay, I am part of this thing. I have particular this much hardware and all other things, okay. And whatever is the containers, we do run on top of the virtual box, on top of this VMware, okay. So they don't share exactly hardware. So they just give like whatever we provide them, they do use it. And the container it itself works VM. Okay, it will feel like okay, I'm a virtual machine myself and all. Yeah, that's about it. Yeah, any more questions here? Okay. Um, I'll just go and install a container, maybe in a small machine. Yeah, maybe I'll in Docker and a Hello World for now. Okay, so we discussed much today, but it will help us going forward because now if you learn Docker and somewhere you will be hearing like okay, someone is using different kind of things. Yeah. Yeah, I'm gonna show the Docker installation from scratch. Okay. Like for now, what I'll think is I'll do complete Docker sessions. I'm not sure if the next week I'll see based on that. So we'll discuss about the Docker, what are all things, and the complete set. Maybe it will take 2-3 sessions. So once it is done, we'll go a brief about the container D or quick CTL or the cryo CTL and all. So we'll spin up a VM. Whatever I have, I already so many things. So that's why I'm going with this. Yeah. Meanwhile, anyone has any questions or do you have any dependency or do you need some information, whatever you're looking for? Yeah. Can you hear me, guys?
Yeah. I can.
Yeah.
Yes, Tatu,
Yeah.
I have one thing.
Yeah. Go ahead.
So I need to. I thought of writing one exam, that cloud practitioner for AWS.
Okay.
So I need some like uh, just a roadmap, like till how much I should learn to just crack it. That cloud
Okay.
practitioner first.
See, Cloud Practitioner is a beginner one. I don't know how they changed the syllabus recently.
Hmm. I mean, I saw a few YouTube videos also, but it seems they are telling too heavy. I just wanted to know, is it okay to learn that heavy, or is it any other simple way just to crack it for now?
Okay, Cloud Concept basics. You'll get EC2, RDS, load balancer, and all. Billing and pricing framework. Responsibility model. See, all these are like basic level. Okay. The problem is they might confuse you when you're writing the interview. Okay. I mean, when you're writing the
Hmm.
exam.
Hmm.
Okay. Yeah, basic things are fine, man. Like, okay, yeah. See, this one is not there earlier. Okay.
Okay.
The ML thing is not there. Now they added. Okay. They keep on changing syllabus and all. So see, there's
Hmm.
a pricing thing you can manage. So this one you need to go ahead and see. Okay. And VPC, the storage, EC2, and this theory part. And what else is there? IAM, yeah, IAM complaints. These things are theoretical. Okay.
Hmm.
Yeah, white papers. Yes, sir. So see, this looks okay. But the problem is like as I told, like they might change the syllabus. Okay. So what I suggest, you go through FAQs. So whatever this work the exam guide they gave, right? So go through these concepts first. Okay. And you have the
Hmm.
FAQs here. Like for every section there is a FAQ. Okay. So EC2. Okay. So you need to go through each and every concept. What is it they're saying? You need to learn. Okay. What do you mean by nitro? Okay. Nitro, I think this is I don't know, maybe they're GPU based or AMD based things and all. Okay. So you have a spot instances, all these things. So it will keep changing with the new features they are providing. And you can use something like, yeah, so for this certification, you need a like learn. Okay. But what I say, you can go with this practice test with these guys,
Hmm.
labs.
Okay.
Yeah. So you can go through FAQs, you can go through the concepts, and you can go through practice test. That should be fine.
Okay.
Yes, sir.
Thank you.
So yeah. So we have our VM ready. Okay. So just go through Docker. install. Mine is Ubuntu, which would be here. OS requirement, install, run the install. Okay. So what they are doing, just basic things. Yeah, if you see here, right? Okay, this particular one. So they are installing Docker container engine. Okay, Docker CE, Docker engine, Docker CLI. They are installing container D. So we'll go about the compose as well. So yeah, that's all. They have the components. So you need to use container D, that's for sure. So in order to do the build, you need compose. It's not mandatory, but yeah, we'll go ahead and okay. We have a shell slippage. Okay, my bad. It has already a Docker thing running. Okay, maybe the automation script also. Yeah, and one other thing, concept which I didn't discuss because I am also not sure about it. So yeah, this Azure container. Okay. So it is running in Azure instances. So I never used it like the Windows containers and all other part. I never used it. So not completely sure how does it work, but maybe we can go through if it is required. We can go through in future or some other time. Yeah. Containers, yes, it's the standard stuff. But if there is a Windows container and all, so that works in a different form. Yeah, and there are containers which might be using GPUs also. So that part also we'll try to look with some example. Okay.
Sasi, your voice is not audible.